In this video, we're going to be talking about subatomic particles, isotopes, and ions. We are analyzing an atom. So what are subatomic particles? Subatomic means smaller than an atom. So these are the particles that are in an atom. They're smaller than an atom. These are tiny particles. And we're going to be talking about protons, neutrons, and electrons. So a proton, represented by P plus, is located in the nucleus, as you can see by these red circles. They have positive charges and a mass of 1 AMU. AMU means atomic mass unit. It's a unit of mass, just like gram. But since these particles are so small, we are making up a unit so that we can talk about them more easily. So 1 atomic mass unit is equal to about 1.7 times 10 to the negative 26 grams. So we are talking about something so tiny. Neutrons, represented by N0, so that superscript is a 0, are also located in the nucleus. These are the green ones. They have no charge, so they're neutral, and they have a mass of 1 AMU. So protons and neutrons are about the same size, and they're both located in the nucleus. Electrons are located in the electron cloud. Those are the little the little blue balls. And they have a negative charge. Their mass is so small that we ignore it. So they have a mass, but since it's so tiny in regards to the mass of the atom as a whole, we say that their mass is 0. So the mass of an atom is really determined by the nucleus. It's the protons plus the neutrons that tell us the mass. So if we have 6 protons and 7 neutrons, we would have a mass of 13 for our atom. The charge is represented by the protons minus the electrons. So protons are positively charged, electrons are negatively charged, so we can get the charge of the overall atom by subtracting them. So if we have the same amount of protons and electrons, let's say we have 3 protons and 3 electrons, we would have 3 minus 3, which is 0, so the atom would have a charge of 0. It would be neutral. But if we have more protons than electrons, let's say we have 3 protons and only 2 electrons, our charge would be a positive 1 charge. It would be positively charged. And if we have more electrons, let's say we have 3 protons and 4 electrons, we would have a negative charge. 3 minus 4 is negative 1. So our atom would be negatively charged. The periodic table tells us 3 important things. The first thing is that number at the top is the atomic number, which is the number of protons. Notice that the elements are arranged from the lowest number of protons, hydrogen, which just has 1, to the highest number of protons, which so far has 118. Scientists are continuing to try and create new and larger atoms. And so that number at the top is called the atomic number, and that is equal to the number of protons. What this means is that magnesium has the atomic number 12, has 12 protons, and will always have 12 protons. If we start talking about an atom that has 11 protons, then we're no longer talking about magnesium. We're now talking about sodium. So the number of protons that an element has will never, ever change. The second thing that the periodic table tells us is that number at the bottom. Notice it's rounded to the hundredths place. This is the average atomic mass. So if we had all of element 23, all of vanadium atoms, every single atom of vanadium, and we took the mass of all of those atoms and then divided by the total number of atoms that we had. So we're calculating the average mass of these atoms. We would get about 50.94 grams. Or 50.94 AMU. The average atomic mass is in units of AMU or grams per mole, and we'll talk about grams per mole in more detail a little bit later. The last thing is that we are told the atomic symbol, the abbreviation. So if somebody is talking about nitrogen, they're talking about element N. Somebody talking about oxygen, element O. So each of these symbols, this is the atomic symbol, and that represents what element we have. So now we're going to move into ions and isotopes. So ions and isotopes are 2 words that represent what happens when we change subatomic particles, when we change the number of subatomic particles. So ions are atoms that have a charge. So what does that mean? It means that they no longer have an equal number of protons and electrons. There are two types of atoms. Cations are positively charged, which means they have that an atom has lost electrons, so now it has fewer electrons than protons. So for example, sodium has 11 protons and 11 electrons, right? If we look at this periodic table, sodium is number 11. It has atomic number 11, which means it has 11 protons. When it's neutral, when it's an atom, it has 11 protons and 11 electrons. When it becomes an ion, it now loses 1 electron, so now it has 10 electrons and 11 protons, so it becomes a positive 1 charge. When you just see a positive sign or just see a negative sign, it means positive 1 or negative 1. If it was positive 2, we would need to write the number 2, so it would be 2 plus. Anions, on the other hand, are negative, which means they have gained electrons. They have more electrons than protons. So for example, sulfur, it has atomic number 16. So it has 16 protons and 16 electrons when it's an atom. When it becomes an ion, it gains 2 electrons. So it becomes S2 minus. It has 2 additional negative charges, right? It has 18 electrons now and 16 protons. So it has 2 more negative charges than positive charges. So the overall charge of our ion is a negative 2 charge. And we now call it sulfide. An anion, when an atom becomes an anion, when it gains electrons, the ending changes to an ide, IDE. Isotopes are atoms of the same element that have different masses. So they have the same exact number of protons because it's the same element, but different number of neutrons. For example, carbon 14, that dash 14 means that it has a mass of 14. So it has 6 protons and 8 neutrons. So remember, 6 plus 8 gives us the mass. The protons plus the neutrons gives us that mass. Whereas carbon 12 still has 6 protons because it's still carbon. I want you to note that here is our carbon. It has atomic number 6. So carbon will always have 6 protons. But it has 6 neutrons as well. So 6 plus 6 gives us 12. So that's where that mass comes from. So carbon 14 and carbon 12 are isotopes. Same exact element. They're both carbon. They both have 6 protons, but different masses, different number of neutrons. So just to really illustrate this, when sodium becomes a cation, it loses an electron. So it has lost this outer electron. So notice it, all that has changed about this is that it's lost 1 electron. So now it has a positive 1 charge. Sulfur, on the other hand, gains 2 electrons. And so now it has more electrons, and so it becomes sulfide ion. Nothing about the nucleus is changing. I know the nucleus isn't really represented in these illustrations, but nothing about the nucleus is changing. Sulfur still has 16 protons. Sodium still has 11 protons. And the number of neutrons doesn't change either. And here are our 3 isotopes of carbon. Carbon 6 has 6 protons, carbon 12 has 6 protons and 6 neutrons. Carbon 13 has 6 protons and 7 neutrons. And carbon 14 has 6 protons and 8 neutrons. So all that's changing is the number of neutrons, which causes the mass to change. So let's do some examples. We're going to fill in the blanks on this table. So just to go over how to do this, the abbreviation or the atomic symbol can be found on the periodic table. Again, the atomic number is also on the periodic table, that top number. The average atomic mass is also on the periodic table, that bottom number. The number of protons is always equal to the atomic number. So that means that this number, whatever is in this column, must equal the number of protons. These are the same. The neutrons are equal to the mass minus the protons, because the protons plus neutrons tells us the mass. And the electrons are equal to the charge of the protons minus the charge, because protons minus electrons gives us that charge. And you'll see the charge in the atomic symbol, if it's there, or be able to calculate it based on the subatomic particles. So here we have oxygen, atomic number 8. So we know it has 8 protons. The neutrons must equal them. So the protons plus the neutrons have to equal the mass. So 16 minus 8 gives us 8 neutrons. And notice that there is no charge up here, no charge at all. And so therefore it also has 8 electrons. The protons and the electrons must be equal if there's no charge. So pause this video and try and fill in the rest of this table. Okay, bismuth, Bi, is located right here on the periodic table. It is number 83. So its atomic number is 83, which means it also has 83 protons. To figure out that the number of neutrons, we're going to be doing the mass minus the number of protons. So it has 126 neutrons. Notice again, there's no charge for bismuth as the atomic symbol. So the electron must equal the protons. So it has 83 electrons as well. F minus, F is fluorine. Since it is an anion, it becomes fluoride. When we look at that periodic table, F is right here. It has atomic number 9 and mass, average atomic mass of 19. So the atomic number is 9. The average atomic mass is 19. Therefore, the number of protons must be 9. It's got to be equal to the atomic number. The number of neutrons, again, is the neutrons plus the protons have to equal the mass. So we're doing the mass minus the protons. 19 minus 9 gives us 10 neutrons. Now we have a charge of -1. It's got a minus sign there, which means that there must be one more negative charge, right? Electrons are negatively charged and protons are positively charged. So if we have a -1 charge and we have 9 protons, we must have 10 electrons. And you can also figure this out by doing our 9 protons minus the charge minus a -1. So 9 minus a -1, which is the same thing as 9 plus 1, gives us our 10 electrons. Pb 208. So Pb is the atomic symbol. Pb stands for lead. And here it is. It's got atomic number 82. In this case, this is a little different. We're not going to use the average atomic mass because we are talking about a specific isotope. So whenever you see either an element name or an atomic symbol dash a number, that is our average atomic mass, or that is our mass. So we're going to use 208 as our mass. Our protons are equal to the atomic number, so that's going to be 82. 208 minus 82 gives us our neutrons, so that's going to be 126. And our number of electrons, this is neutral, there's no charge, so our number of electrons equals our number of protons, so that's going to be 82. For our last one, we are told the average atomic mass is 55.845. So that's iron, 55.85, that's the closest. It's got atomic number of 26. Oops, sorry, I'd lost my mouse. Atomic number 26, atomic symbol Fe, that is iron, which means it has 26 protons. And we're going to round this to 56. 56 minus 26, right, because this is an 8, so it ticks that up. So we're going to say 30 neutrons. It has 23 electrons, 26 protons. 26 minus 23 gives us a +3 charge. So that's going to be the charge there.